Today we're going to be talking about geometric sequences. If you'll remember from this fall, we talked about arithmetic sequences. You should already have notes on those, but just to refresh, an arithmetic sequence would look something like 3, 5, 7, 9. And each time in this sequence, I'm adding plus 2, plus 2, plus 2. Because in an arithmetic sequence, I'm looking for that common difference. But in a geometric sequence, which is what we're going to be talking about today, a geometric sequence would look something more like 1, 5, 25, 125. And if you can tell, each time I'm multiplying by 5, and by 5. So instead of looking for a common difference, I am now looking for a common ratio, which we will denote as R. So we can be looking at some examples here. We'll start with 256, 128, 64, 32. Well, the first one I looked at, that 5, 20, 1, 5, 25, 125, I was multiplying by 5, and I was getting bigger from that 1 to the 125. Here I'm starting at something that's 256, and I'm getting much, much smaller. So instead of multiplying by a whole number like 5, I'm probably multiplying by a fraction. Can anybody figure out what fraction I might be multiplying by each time I move on? Good. Each one is half the previous one, so I'm multiplying by 1/2 each time I'm moving. So my common ratio would be 1/2. And this is a geometric sequence. So try this one. We have 4, 9, 12, and 18. Tell me if it's arithmetic, geometric, or none of the above. Something else we can do with geometric sequences is we can find the next 3 terms. So let's say I have a sequence that starts with 1, then it goes to -4, then to 16, then to -64, and so on. So the first thing I need to do if I'm wanting to find the next 3 terms is I need to know what that common ratio is. So what am I multiplying each time? So from 1 to -4, I multiply by -4. Now does that work from -4 to 16? Well, a negative times a negative is a positive, so in fact it does. So my common ratio is -4. So to find my next 3 terms, I'm going to start with my -64 and multiply by -4. That would give me 256. Then I take 256 and multiply by -4. That would give me -1024. Then I start with the -1024 and multiply by -4. So find out what that last, or that, not the last term in the sequence, but the 7th term in the sequence would be. Good, we should have gotten 4096. So try this one, finding the next 3 terms on your own. We'll start with 9, 3, 1, and 1/3. We should have found the common difference is 1/3. Or not the common difference, the common ratio. So if I multiply 1/3 by 1/3, I get 1/9. If I do 1/9 by 1/3, I get 1 over 27. And if I do 1 over 27 by 1/3, I get 1 over 81. So my next three terms are 1/9, 1/27, and 181. 1 over 81, sorry. And just like I can find the next three terms, I can also find any term I really want. And we'll call that finding the nth term. So we did this with arithmetic sequences, and we had a formula. And just like we did it with arithmetic sequences, we will have a formula for geometric sequences. And our form for geometric sequences will be a sub n equals a sub 1. Remember, that's our first term. Times r, and we know that's our common ratio, to the n minus 1. And this is where our exponential functions are coming into play here. Okay? Because we're raising it to the power n minus 1. So, let's start by looking at an example. Our sequence starts with -6, 12, -24, and 48. So a few things we want to know. I'm going to ask you to find the 9th term in the sequence. So n is going to be 9, okay? And I'm kind of arbitrarily picking that because that's what my problem tells me. It wants to find the nth or the 9th term. So n is 9. But things that I can gain from this sequence that I already know my a sub 1 term because that's the first term in the sequence, and that's -6. I also know my common difference. To get from -6 to 12, I multiplied by -2. Okay, so I have all the variables I need. So I'm going to start plugging them in, and I want to find the 9th term, so that's a sub 9. We'll make sure we know that's an a and a 9. So I have a sub 9 equal to my a sub 1 term, which is -6, times -2 to the 9 minus 1. Well, 9 minus 1 is 8, so I have -2 to the 8th times -6. -2 to the 8th, we can figure out, is 256. 256 times -6 will give me -1536. And that is my 9th term in this sequence. Okay? So let's try one of these on our own. We're going to start with a sequence that is 96, 48, 24, 12, and so on. Okay? And I want you to find me the 10th term in the sequence. So n is going to be 10. Find out what r is. Tell me what a sub 1 is. And then we can plug that in and find the 10th term in the sequence. But first give me r and a sub 1. We should have gotten that r is 1/2 and a sub 1 is 96. Now let's go ahead and plug that in. A sub 10 equals 96 times 1/2 to the 10 minus 1 power. Let's see if we can figure out and simplify that down and find out what the 10th term in the sequence is, or what a sub 10 is. So following that work, we have 1/2 to the 9th power. That would give me 1 over 512, which is times 96 over 1 gives me 96 over 512. I do need to reduce that, and I get 3/16 as my answer.